Hello, everyone. This is Michael E Yeaman with another Geology of Sculpting Stone. Today, we're going to talk about British Columbia jade. So, why should you even care about the geology of your stone? Well, stone sculpture is one of the very few art forms that date back to the very beginning of recorded history. And the story of stone is always unique. Therefore, knowing more about the geology of your stone will allow you as stone sculptors to select specific stone types that have a compelling history for you and your viewers, to marvel at the stone's various elements of color, texture, and composition as you work it and to understand them better, to consider how the sculpture's chosen artistic form, your chosen artistic form, relates to the science of the stone, and finally to find a way to weave into your final artwork a geologic story component that enhances the interest in the work for you and potential buyers. And as usual for the Geology of Sculpting Stone series, we'll take a look at three individual sections. We'll start by looking at the stone defined, its general description, physical and chemical properties, and historic use. We'll look at specimens, both large scale and small scale. And we'll take a look at specific occurrences where you could find the stone today. Then we'll dive into its geology, its age and description, the formation environment and processes that were occurring when the stone was formed, where the stone was being formed in the global paleogeographic setting, and if there's any modern analogs of where you might find the stone forming today. And then finally, we'll take a look at select creations both in art and architecture. So let's begin by taking a look at the general description, physical and chemical properties, and historic use for jade. Jade is a generic term that includes two key minerals, jadeite and nephrite, and although this presentation will focus mostly on local British Columbia jade, which is nephrite, the two minerals will be compared and contrasted for reference. BC nephrite is located in central BC and along a north-south corridor running from the U.S. border all the way up to the Yukon Territory. And historically, three major areas have been quarried in BC for nephrite. A southern area, the Bridge River segment northeast of Vancouver, a central area, the Mount Ogden area northwest of Prince George, and finally the Cry and Durst Lake segment just south of the BC-Yukon border. First Nations began using jade quite a while ago, perhaps as long as 1000 BC or earlier, across the British Columbia Plateau. Early uses include various types of tools and weapons because of jade's particularly hardened, and it evolved into precious stone use for prize objects later. Jade became the official mineral emblem of British Columbia in 1968. And over the past 25 years, exports of BC nephrite have averaged over 200 tons a year, therefore extracting more jade in 1 year than the entire prehistory for mankind. Oh, by the way, on the right here, you see the composition of the two major components of jade, jadeite being a aluminum sodium silicate, and nephrite having more of a calcium iron magnesium component along with a silica and oxide element. We'll talk a little bit more about why they differ as we go down the line. Let's begin by taking a look at locations. Well, if you look at jadeite locations worldwide, here shown here as the boxes, you can see they're oftentimes affiliated with this thing called blue schist. Now, blue schist is a type of change of a rock, a metamorphic type of a change of a rock, and we'll discuss why they are affiliated with blue schist metamorphic rocks as we go and explore the topic a little bit further. If we take a look at global nephrite locations, on the other hand, you can see that their locations here, shown by the small little circles, affiliated with the word ophiolite. Nephrite, and there are two different varieties, two different subsets that oftentimes refer to those that involve a type of limestone called dolomite and another type that involve a metamorphic rock called serpentinite. But you can see that both those types are heavily affiliated with this rock type called an ophiolite, and we'll discuss a little bit what an ophiolite is and why they are associated with nephrite. Now let's begin by looking at specimens at the large scale. So here's some really macro size pieces of jade. Oftentimes we think of jade, of course, as an amazing piece of stone for jewelry, a gem quality jade. but it occurs in very large pieces for various reasons, which we'll discuss in a minute. So here we have 4 human-sized pieces, giant boulders of jade. Now, if we take a look at the thin sections, and if you recall what a thin section is, it's a very thin piece of the rock, sliced so thin that you can actually see light through it. And then we shine different types of light, in this case polarized light, which brings light in one type of orientation through the stone, and we magnify it here about 100 times. Now you can see the difference between nephrite and jadeite, and in nephrite you can see that the character of the stone is a fibrous, felted, interwoven pattern of these grains. It certainly has that fibrous element to it that is quite outstanding in this slide by the color contrast in the stone. And for comparison, if we take a look at jadeite, we can see that more of a conventional crystalline formation is occurring here in this thin section with interlocking grains. Now, both of these produce a very hard stone, particularly for jadeite with its interlocking grains, and pretty in thin section. Now, if we spend a little bit more time about the specific occurrences of BC nephrite, here we have a map of British Columbia with the 3 major areas we talked about, the Cry and Dease Lakes areas, the Mount Ogden area, and then finally the Bridge River area in southern BC, where past and present producers are occurring. And you can see that they line up, as we discussed, in this north-south pattern, which we'll talk about why they do in a few minutes. And here's a picture of some samples of jade from each of the 3 areas. By the way, once again, here is our formation or tie to this blue schist rock, which we'll talk a little bit more about here in a minute. Now, if we drill down into one specific area in the Mount Ogden area, I have some photographs here from an old article that shows operations beginning in the 70s and then a view of the deposit here in the late 90s. And just to give you a sense of the land and the vegetation and the tools, many of these locations are really quite remote. So getting high quality industrial tools to these sites has really never been easy. And then their elevation oftentimes makes them very prone to weather conditions in the wintertime, which prevent operations. But here we have a couple different views, the base camp in the 70s and the overlying pit area with the framework, and then the large saws, big circular saws here, and the front end loader here to the right for current operations. These type of operations are oftentimes on a seasonal basis because of weather operations, as most of these locations in British Columbia are fairly mountainous. Another specific occurrence, a place to find jade, is downstream from major jade-producing outcrops like the Lower Fraser. Here you could find what's referred to as float jade, or jade which has been brought down either by fluvial sources like the Fraser River or by glacial events over the past 30 or 40,000 years. And many of them produce large gravel bars which contain some really very large and quite outstanding pieces of jade. The advantage of the jade found in these locations is that much of it has been rolled and stressed, and all the weak and softer elements of pseudo jade have been broken free, and oftentimes what you're left with is a piece of 100% pure nephritic jade. And nowadays it's a lot easier to work a gravel bar to Lower Fraser than is in this lower right photograph, with the Fraser at one time was a big gold panning areas. Nowadays, you can make a lot more money per hour by looking for nephritic jade boulders than you can with an old sluice. Now, if we go into the age and geologic description of jade, and specifically nephrite, let's just start with a few basics. So we talked about in the past how there are 3 major types of rock: sedimentary, igneous, and metamorphic. You probably know that already. A core component of igneous rocks, and occasionally metamorphics, are 2 major types or subcategories of particularly ferromagnesium rocks, and they're pyroxene and amphibole. Now, jadeite is actually a subset of one of these rocks, the pyroxene, And nephrite is a subset of one of these other major metamorphic rocks that are amphiboles. So jadeite and nephrite are specific types of common metamorphic rocks, even though both jadeite and nephrite are unusual and rare within these subcategories of pyroxene and amphibole. To spend a little bit more time discussing pyroxene and amphibole, here is a little table that contrasts their chemical composition, their colors, other elements, other mineralogical elements like cleavage, how easily it breaks, and what type of breaking it occurs, how hard it is, how dense it is, its specific gravity, what sort of luster or gleam you'll have off the rock. And then streak is referred to as the color of streak or left behind mark that if you were to scratch the rock over a plate, a tile plate, it would leave behind. So you can see that aside from some variations in chemical formulas, both the amphiboles and the pyroxenes have a lot in common, both in color and in cleavage and in hardness. And really, from a lot of characteristics, there's hard to differentiate it. Now, if we look down below the two rocks that come from the two respective or subsets within this respective metamorphic category, jadeite for pyroxene and nephrite for amphibole, you can see here's our chemical formulas again. The jadeite not containing any iron or magnesium and having sodium as its major cation compared to calcium for the nephrite. They're similar, with jadeite being rather harder than nephrite, and the fracture strength actually of nephrite is quite a bit higher than it is for jadeite. But for a lot of characteristics, especially the source of the metamorphic rock they came from, they share an early history in common. Now let's talk a little bit about the concept of metamorphic facies and how that relates to jade. So when we refer to metamorphic, as we were discussing a few slides back, we're talking about a rock, a sedimentary, igneous, or metamorphic rock that's gone under some form of transformation that is achieved by a change in pressure and temperature on the rock itself. Now, there's actually another element involved in metamorphic formation, which involves the movement of fluids, metasomatic metamorphism. And we'll talk a little bit more about that later. But in general, most of the time when we refer to metamorphic rocks, we talk about what changes these rocks have gone through as they've been buried and warmed up. So here we have a map, a little table, where pressure on the vertical axis, increasing pressure from 0 to 12 kilobars down the left-hand side. And then an increase in temperature from 0 all the way up to 800 C, quite hot, across the horizontal scale. And what geologists have done is they've named these different zones where you combine different types of pressure and temperature, and they've given a name for the type of rocks or the facies of rocks you'll find at various temperatures and pressures. So for example, here we have on this map, on this chart, the location of nephrite's formation, temperature and pressure to be kind of midway in the temperature change, about 400 to 500 degrees Celsius, and about midway in the pressure change, about 7 to 8 kilobars of pressure. So therefore, nephrite has a chance to form when you have these temperature and pressure conditions. You can see that jadeite involves much more pressure and lower temperatures than nephrite. But as a comparison, you can see where jadeite and nephrite sit in the overall metamorphic facies, how geologists describe changes that happen to rock when they get buried and warmed up. Now, if we look at nephrite in particular and talk about the different metamorphic grades, in other words, changes in temperature and pressure, and what we call index minerals, minerals that we find in rocks that suggest they are in those temperature and pressure conditions, what you can see is what we see here is the parent, or where this rock begins, as a mafic, or a rock that contains a fair amount of iron and magnesium, starting out as where the rock begins as the parent rock, and then as it goes through increasing temperature and pressure from low grade to intermediate grade to high grade, different minerals, key index minerals, can be found. Chlorite in low pressure, low grade metamorphic facies, green schist metamorphic facies, all the way to some complex pyroxenes, all the way into high grade. Our nephrite body here, our nephrite world, exists somewhere between the low and the intermediate grade here in this overall pattern of metamorphic transition from low grade to high grade. And below here, at the bottom of the picture, we have different rocks formed as we move across this gradational change in temperature and pressure. From basalt on the left, the parent rock, to greenstone in green schist facies, to amphibole schist in intermediate facies, all the way to pyroxene granulite in the high pressure, high temperature facies. And as we said ourselves a moment ago, our little nephrite guy, he's in the intermediate to low grade world. Now let's look at the formation environment and processes. Well, here we are back again with our old friend plate tectonics and another picture of a cross section of the Earth's surface as we discuss plate tectonics and have an overview of how this relates to the formation of jade. Well, here I want to zoom in on this area I boxed, and as we know, that in plate tectonics, our lithosphere, our little section of the Earth, is made up of relatively thin plates, a few tens of miles at most, and they move past each other, slowly moving across the surface. Occasionally, these plates will interact by converging or crunching together. And when they crunch together, we have a situation like we're seeing within this box, that the subduction, the pushing down of one plate below another, creates a boundary, much like we have modern day right now in Washington State, with the North American craton, a solid massive plate here represented diagrammatically on the right, and the oceanic crust subducting or diving down below the continental crust here, showing it plunging down to the right here from this oceanic spreading ridge. Now, we have good evidence to believe, based on the metamorphic rock index minerals, its location, and our understanding of how the metamorphism occurs for jade, that jade is produced by and large at one of these subducting or collision boundaries in plate tectonics. And let's zoom in a little bit now into specifically how this works. Well, when the spreading ridge forms, and we're talking about this area near a thin section of the Earth's crust where it begins to spread apart and magma from the mantle wells up, that's represented here on the left by this area called the ophiolite sequence. Now, when this rift occurs in the Earth's crust along this mid-ocean ridge environments, almost always below the surface of the sea, you get a standard cross-section or column, stratigraphic column of rocks being formed, and they're called an ophiolite sequence. And they begin with these ultramafic mantle rocks from below. Then forming above them are these intrusions into the shallow Earth lithosphere above them. Then some of that highly iron and magnesium-rich material will be in contact with the water and form volcanic deposits. And because they form in the water column underneath the sea, they are pelolavas or pelobasalts, another category all in themselves. And then finally a thin veneer of marine sediments deposited on top of them. Now this ophiolite sequence, as it moves away from the spreading ridge, and our little diagram here moves to the right and collides here with this big granitic mass, this craton to the right side of this diagram. And you can see that as the plate goes down, it gets, as you can imagine, buried and loaded on top with more rock, and that increases the pressure. And its burial or its diving down underneath the plate on the right increases its temperature. And you can see I've mapped here now the metamorphic facies that it would exist depending upon the temperature and pressure that this subducting plate of ophiolite would feel as it subducts or dives down to the right. Now, some of this material of this ophiolite sequence, as it dives down underneath the plate to the right, actually gets scraped off. And this scraped off of this mafic and some pelobasalts, occasionally chunks of ultramafic rock, gets scraped off and actually plastered on the bottom of the plate they're diving underneath. Oftentimes that's talked about as being instead of subduction, where the plate dives down below, the material that gets attached to the bottom of the plate it's diving underneath is referred to as being abducted, or basically stuck onto the lower plate. And it's that material which contains these pelobasalts, some mafics, and some ultramafic rocks that can begin to go through this blue schist facies transformation, which part of which will begin to lead to, on rare occasions, the formation of jade. And as I mentioned down here in the last bullet point below at the bottom of the slide, some of this ultramafic rock is scraped off, and some of the processes occurring besides the pressure and temperature of the blue schist facies can also occur by metasomatic exchange, basically fluid exchange that can occur at the same time. And during that exchange, the nephrite formation process can begin to produce what we would call our nephritic or BC Jade, including also other impurities like chromite, magnetite, diopside, chlorite, talc, etc. Something we'll see affiliated with nephritic jade as we take a look at a few examples here in just a few slides. Now, once again, let's go back and take a look at our formation environment and setting. So here we have a picture of British Columbia with our north-south segment again, with our three major segments producing or showing to have produced nephritic or BC jade. And you can see that on this slide, taken from a geologic article, what they refer to as the nephrite-bearing belt exists along one of these subducting zones under central British Columbia. And you can see that the age of this subduction, it dates back into the Mesozoic, so it dates back into over 100 million years ago when this particular subduction that produced the BC jade occurred. If we take a look now at the Mount Ogden area in central British Columbia as an example of one of these locations that have a BC nephrite, you can see the map of the geology here on the left with the color code referring to different ages of rock. And the stars, 1, 2, and 3, refer to specific nephrite locales within the section. You can see number 3 is located by that line with the arrows. That's a fault zone. And 1 and 2 sit within what's referred to as the PJCCU subset, which is this ultramafic unit, serpentinized ultramafic, and various types of metamorphic rocks that we've been discussing listed there in this one geologic zone. In the lower right here, by the way, I've also put in a cross-section of 63 magnification showing this standard, quite characteristic nephritic pattern of these interlocking fibrous grains, which make nephrite as tough of a stone as it's known to be. Let's take a look at a few detailed spots in the Mount Ogden area where they have mined nephrite. Now here I begin with idealized cross-section on the upper left that I've rotated 90 degrees to match the photograph to its right. So let's walk through this. An idealized cross-section in this area would begin by having serpentine. And what serpentinite or serpentine is it's a metamorphic version of that mafic, volcanic, pelobasalts, and other mantle material that has been abducted onto the plate, like we talked about a couple of slides before. And this volcanic material goes through its own metamorphic process and is produces a rock that goes by the name of serpentinite, of which it provides the parent or host rock for the formation of nephrite. Now, oftentimes in fault contact, that heavy dashed line, Right above it, or in association with it, is a zone or a lens of nephrite. And then above the nephrite, or adjacent to the nephrite, is a white rock, often a talc rock, another metamorphic rock produced in the blue schist facies of the nephrite formation. And then it will grade back into a silica-rich country rock. So that's the idealized cross-section. So what do we see in this photograph to the right? Well, it's black and white, so some of the colors you're going to have to interpolate. But on the left, you see a thick greenish block of rock. That's the serpentinite, and you see with the arrow pointing to a rim, or almost a dike-looking type block of rock that's blocky. That's the nephrite. And then to the right of that, you can get a sense of the character changing again. That is the white rock, in this case talc, that's in contact with the nephrite. And then off to the right is the silica-rich country rock. So this photograph shows at an angle what the standard idealized cross-section of BC nephrite would be, beginning with serpentinite, this altered metamorphic pelobasalt mafic rock, going into nephrite, and then adjacent to that, a white metamorphic talcish type rock. On the lower left, I have another picture. Here we've kind of flipped the orientation. The serpentinite is on the right, and it grades through a semi-nephrite. You can see the transition in character here in the center into 100% nephrite on the left. And then finally, one more photograph here in the lower right, where the big blocky chunk of nephrite there by the darker hues is bounded by both coarse and fine-grained white rock, probably talc, on the right and left of it. The notebook there in the photograph's about 11 inches tall. Now, if we step into taking a look at what the global paleogeographic setting was when the BC nephrite jade was being formed, we have a picture that looks quite different than the present Earth's surface. It takes place in the early Jurassic, middle of the Mesozoic, about 195 million years ago. I hear from a rather brilliant geologist by the name of Sculpting, who's put together a series of paleo maps over the years of what the continents looked like during different stages of the Earth's history. We see he's labeled here areas would ultimately would become Africa and South America, Australia and Antarctica, India. And the chunk here being pointed to the north is a piece of North America, which is barely recognizable before it split off from the other continental land masses. But here at the time, on the west coast of this Paleo North America, a subduction was occurring, a diving down of one oceanic plate underneath the North American continental plate, and that was the process that would lead to our nephrite. If we drill down a bit and magnify what was actually happening off the coast of ancestral North America, we actually see not one but two subduction zones happening at the time. One right up against North America underneath the Slide Mountain Ocean, and one of a series of intermontane islands subducting a little bit further to the west. This aggregation conveyor belt of processes produced a lot of the land west of the nephritic belt of British Columbia today, and the subduction process glued on elements of islands and other microcontinents on the western North America as it subducted underneath the ancestral North American continent. One thing they did was abduct some elements of these ultramafic and mafic rocks that were produced at the mid-ocean ridge spreading centers to the west of this diagram. And those ultramafic rocks that were abducted and ultimately uplifted and exposed, a couple of those zones led to zones or areas within British Columbia that produced nephritic jade. Well, are there any modern analogs that are presently producing jade today? Abducting plates and metamorphic processes that might be producing jade? Well, hey, subduction is still going on under western North America. It's just continuing to move out further to the west as additional island arcs and micro terrains have been aggregated, subducted and abducted, collided with western North America. And today we have one happening right off the coast of British Columbia and Washington State. We call it the Juan de Fuca Ridge. And that subduction belt, that conveyor belt of subducting plates, is diving underneath the coast of Washington State and British Columbia right now. It's leading to elements that are probably being abducted underneath the plate as it scrapes that material off and dives down underneath North America. And as we know, some of the magma comes back up to the surface as the lovely Cascade Range of mountains and volcanoes all the way from south central British Columbia down into Northern California. So could be nephrite and jade is being formed thousands of feet below Washington State even today. So let's take a look now at some art being produced from nephrite and jade overall. Well, as sure all of you know, jade is viewed to be one of the very precious stones for jewelry and small pieces, really from the beginning of carving stone, particularly in the Far East and particularly China. China, throughout most of its history, focused on its nephrite jade, ultimately began to use some Burmese jadeite, which was particularly popular the last couple hundred years. But early in Chinese history, nephritic jade was used to make magnificent sculptures like this art form called a Kong from 4000 BC and all the way for thousands of years into making all sorts of different small and fairly large sculptures out of nephritic Chinese jade, including some lovely things like this great Wu controls the flood all the way from the 18th century, unbelievable detailed carving in jade. Fabergé used jade along with diamonds in the 19th century for eyeglass cases. But it doesn't have to be just ancient art or Art Deco glass cases. You know, our sculptors here in the Northwest Stone Sculptors Association, many of them have used jade to make oftentimes small pieces in beauty of many different forms. And our own Deborah Wilson, probably one of the world's most well-known and greatest carvers of nephritic jade, has produced some very large pieces over the years. Here are just three of them. What about architecture and jade? Well, are you kidding? We're talking about jade. So jade is even semi-nephritic jade is still very valuable. And so very large blocky pieces, those enormous boulders and things, would normally not be used for architecture, although there are some exceptions. And some exceptions are extremely unusual, lit tiles in jade or semi-nephritic countertops and other beautiful sculptured walls. But by and large, jade is certainly not used in any form of architecture. It's just too valuable, although frankly, certain times in the past did see jade used in certain ancient architectural forms, and it's very durable, right? So it's a very hard to break, and nephritic jade with its fibrous character makes it unlikely to fracture or cleave along a flat surface. So it makes it a very durable material. It's one of the reasons it was used for Paleolithic tools for thousands of years, and jade pieces today look as oftentimes as new as when they were made. In conclusion, what can you say about the geology of sculpting stone, BC nephritic jade? Well, it's a beautiful stone. It's a rare stone. It's a hard stone. And because of this, it's only rarely carved into large pieces, Deborah Wilson producing some of the more beautiful examples I know of. And most of you may know that every year at the NWSSA Sculpting Retreat at Pilgrim Firs, we have a jade tent where many people can come and create many lovely objects, both small and medium sized. I anticipate we'll be doing this for many years in the future because the love of the NWSSA of jade and jade sculpture is strong. So ends another Geology of Sculpting Stone by Michael E Yeaman. See you next time. Bye-bye.